Hello. My name is Tino Longley, and yeah, this is my submission for homework graphic homework 5, which is the texture mapping. So for this homework, we supposed to basically handle the UV mapping on like a spherical object, and so this is well, our team showcase of what we did. So the picture right here is basically the output that we got. So the original code is the cube, texture mapping on a cube. We're supposed to replace the cube with a sphere and then do some extra code that just basically handle the sphere. And let me go over what I kind of did for the code wise. So the first thing is I just replaced the object file from a cube to a sphere. And yeah, that's just basically what this yellow line of code do. And then let's move on to the second part, which is more important, which is the private static intersection intersect ray sphere. So the purpose of this class is not class, but method is to determine if the ray intersect with a sphere and then calculate the intersection point and normal. The ray parameter is just the ray being traced. The center is the center sphere and the radius is radius of sphere. The vector tree OC, no, not there. Vector tree OC is basically subtract the sphere center from the ray origin to get the vector from the ray origin to the sphere center. This vector is just basically used in like a ray sphere intersection formula. And then moving down to double A, that would just basically compute like a dot product of the ray direction vector by with itself. And then let's see, double B right here. Oh, double B would just like compute 2 times OC dot ray direction. That's just where the OC is the vector, or OC would mean the origin. Yeah. Let's see. Yeah, it's called OC. It is calculate where the OC is the vector from the ray origin to the sphere center. This is just another term in like the quadratic equation. And then moving on to double C, that just basically compute OC times OC minus radius squared. This is where OC times OC is the square length of the vector OC. And this is just the final term in the quadratic formula. And then the double discriminant is just compute the discriminant of the quadratic equation. And the discriminant just determine whether the ray intersect with the sphere. So if the discriminant right here is less than 0, there will be no intersection. But if the discriminant is more or equal to 0, the intersection exists. Let's see, let's say there. The double T right here just basically solve the quadratic equation to find like the smallest possible T value, which is just the distance along the ray to the intersection point. And then that just check if T is positive, the vector 3 point and vector 3 normal. The vector 3 point just basically compute the intersection point by scaling the ray direction by T and adding the ray origin. And then the normal just compute the normal vector at the intersection point by subtracting the sphere center from the intersection point and normalization result. And normalizing the result. And just this normal is just basically used for like shading and texture mapping. And then you just return the intersection detail. So this will basically return if hit equal true, indicate a valid intersection, and then the distance of the intersection point. And else, just return false. Cool. So that's the main bulk of the code I work on, but I also add in, where is it? The vector tree add and vector tree multiply. Vector tree add, it just basically add two vector component-wise. The v here is just the vector to add to the current vector, and then it will return like a new vector tree object representing the sum of two vector. Similarly, multiply double scalar is the purpose of it just to scale a vector by a scalar value. And the scalar value here is just to multiply the vector by. And it will return like a new vector tree object representing like the scale vector like I said earlier. And that's just pretty much all I did for this code. And our result come out to the sphere that I showed you earlier where the wood grain is showing the texture right here. Thank you very much.